All right, we have finally reached 4.3. So this has been a super long chapter so far. It's a couple sections. And today we're going to be talking about the remainder theorem and synthetic division. So I wrote these I cans too because I think they're important to kind of remember that what we're doing is deciding whether something is a factor and finding all of the factors. So the remainder theorem is super mathy and slightly scary, and I wouldn't blame you if you didn't like it. So the remainder theorem says that if the polynomial p of x is divided by a factor, which I'm going to call x minus r, okay, that's a factor, then the remainder is a constant p of r. Okay, so, and then that means like if I plugged in this number r, my answer would be something, the polynomial evaluated at that number r. And then the important part that we're really going to talk about today is that p of x is that factor, x minus r, times the quotient, whatever's left, plus the remainder. Okay, and that's the remainder. So where the quotient, q of x, is a polynomial, this looks so frightening, polynomial of 1 degree less than p of x. Okay. So once you write this down, I'm gonna put this into some words different than what we've done. Or I mean similar. Okay. So what I mean by this is if I gave you this, let's say, how many times does 5 divide into 36? Hopefully you remember doing this at some point in your life. Let's change it. Hopefully you didn't write that down. Let's say 67. That'll work better. So 5 divides into 67. So the first thing that you used to do was like determine how many times does 5 go into 6. And so 5 goes into 6 one time. And then 5 times 1 is 5. And then if you remember, you would subtract. 6 times 5 is 1. And then you bring down the 7. And then you would, how many times does 5 go into 17? And the answer would be 3. 5 times 3 is 15. 2 was here, and there's nothing else to bring down. So then you would say remainder 2. Okay, hopefully you remember that. So if I asked you, is 5 a factor of 67? You would say no, and hopefully you would say no because there's a remainder. I hope you would say no because there's a remainder. So similarly, how do we find out a polynomial? So I'm going to go like this. Is a minus 2 a factor of 2a squared plus 3a minus 8? Okay, so I'm going to do the same thing again, but now I'm doing polynomial long division. Okay, so we're going to take this step by step. How many times does a go into 2a squared? So a times what would be 2a squared? A times 2a would be 2a squared. So like a, if we took a and we multiplied by 2a, I'd get 2a squared. So I'm going to multiply these together and I get 2a squared, but I can't forget about this negative 2. So 2a times negative 2 is minus 4a. Okay, so just like we've done this step now, and then we did this step here. So we have to subtract now. So if I subtract, I need to make sure that I subtract both pieces. So I'm going to kind of put a parenthesis around it. Okay, so 2a squared minus 2a squared. Hopefully that you see that these drop out, and I'm left with 0a squared, and that's good. Now I have 3a squared minus negative 4a. So when you minus a negative, you plus a positive. So here I get 7a. And then just like here, I need to bring down the 8, and it's negative 8. So minus 8. Okay, so I'm following the same steps. Then I go over here, and I see that I need to like do this again, right? Because I decided over here 5 went into 15 3 times. So how many times would I take A to get into 7A? So I'm going to put plus 7 up here. So A times 7 is 7A. And minus 2 times 7 is minus 14. Same thing again, I'm going to subtract. These cancel out, but I'm subtracting. So negative 8 minus a negative 14 turns into plus a positive, and then I get 6. And just like over here, like 2 was my remainder, 6 is my remainder. So then I'm going to write remainder 6. So is A minus 2A factor? No, because the answer is not 0. I could also, if we think about the remainder theorem and what we've talked about, if A minus 2 is a factor, then I should be able to plug in P of 2 and get 0 out. So if I did that, for example, I would do 2 times 2 squared plus 3 times 2 minus 8, right? I'm just plugging it in our original 2A squared plus 3A minus 8. So this is 4, so I get 8 plus 6 minus 8. Does that equal 0? No, and look at, this is our remainder. Like, I get a remainder, it does not equal 0, it equals 6, which is our remainder. Okay, so things are kind of like lining up. Also, here's the good news. I will never, ever make you do polynomial long division again unless it's like an A cubed. There's only a couple times I'll make you, so I shouldn't say never, ever. But polynomial long division sucks. Boo. Okay, what am I going to have you do instead? I'm going to have you do synthetic division. So I'm going to walk you through a synthetic division here using the same idea. So let me get a blank slide up here and I'll do it. Okay, so polynomial long division. I want to know, is A minus 2 a factor of 2A squared plus 3A minus 8? Okay, so steps to polynomial long division. You're going to use the 0. In this case, when I change it, that doesn't even look like the word 0. Okay, the 0 is positive 2, right? If A minus 2 is the factor, then the 0 is 2. And then I'm going to put all the coefficients in a line next to it. So if you were like making steps, step number 1 would be use the factor. Sorry, use the 0. Okay, number 2 would be line up coefficients. Okay, so 2, 3, negative 8. Step 3, draw an arrow. That doesn't look like draw an arrow, but it is. And a line. Draw an arrow and a line. Okay, that arrow indicates that you are going to bring the number 2 down. Okay, so don't forget that arrow because it's a good placeholder, but also it reminds you to bring the 2 down. 4 is going to be to multiply in your steps. So 2 times 2 is 4. I'm going to write it here. Okay, 2 times 2 is 4. Then you're going to add. So here's the great thing about synthetic division is that you get to add. Polynomial line division involves subtraction, and it always goes wrong. For me, I always make a mistake when I'm subtracting. So you get to add. You're going to add down. So I get 7. Okay, step 6 is to repeat. 7 times 2 is 14. I'm going to put that here. Add down, I get 6. Important things to remember, this last number is your remainder. You should work, this is going to feel weird, you're going to work backwards from right to left. Okay, so remainder is first, then this is your constant, then this is your x. Now notice, it would be a, it's 1 less here, right? This is a squared, the degree on this one is 1. So how to interpret your answer? 2x plus 7, remainder 6 is how I interpret this answer. Yes, I will do another one for you. Okay, but I'm going to follow these same steps. One more example. Okay, is x minus 3 a factor of this polynomial? So step 1, use the 0. If x minus 3 is the factor, 3 is the 0. You're going to put it in a corner. Now I'm going to list the coefficients. 1, -1, -5, -3. Draw an arrow. Bring it down. Now you're going to start your multiply and add. 1 times 3 is 3. Put it here. Add 2. 2 times 3 is 6. Add. Bring it down. Multiply. This should be positive 1. I made a mistake. Don't want to make 3 mistakes or 2 mistakes like I did last time. 3. Add down 0. Okay, now we work from right to left, so it seems weird. Remainder. Constant. X. X squared. Notice my answer is going to be x squared, and this is x cubed. These are the coefficients. 1x squared plus 2x plus 1, remainder 0. Is it a factor? Yes. How do I know? There was no remainder. Okay. If I asked you to find all of the factors of this x cubed, I would say take this here. Can you factor this? You can. Okay, you can factor it into x plus 1 times x plus 1. So what are all the factors of x cubed minus x squared minus 5x minus 3? The 3 factors are x minus 3, x plus 1, and x plus 1. Okay, so then the zeros, one step further, are 3 and -1 twice.